Everyone, let's solve the main LeetCode challenge. And today is the day 15, and the problem is maximum sum in circular subarray. So, given is circular array C of integer represented by A, find the maximum possible sum of the non-empty subarrays C. Here, a circular subarray means that the end of the array connects to the beginning of the array. Formally, C of I is equal to A of I when I all I lie between 0 to 1 length of array, and once we reach the length of array, then it will reach to the C of I. So C of I plus A dot length is equal to C of I for every I greater than equal to 0. Also, the subarray may be only include each element of the fixed buffer A at most once. Formally, this Ci plus 1 there does not exist any k1 and k2 lie between 1 I and j with k1 mod a dot length equal to k2. Okay, so we have to find out the maximum of sum while also considering if we remove the circular constraint. So this is very simple as a very known standard problem, maximum sum subarray, which can be solved using the Kadane algorithm. If you're not already familiar with that, I would recommend to better to solve that problem first. I will put the link in the description. So given the example here, like 1 minus 2 3 minus 2, so if we see the subarray, this only has the maximum sum. Let's see example 3. So example 2, here in example 2 we can get the subarray like 5 and 5, like be this and this element. Let me draw this picture. So there are two cases here. So one sub case, our sub maximum sum of the subarray can be in the array lie between the array itself, like this one, like this one. So it can be exist here only itself in the array between 0 to n minus 1 index, or the maximum sub array sum can go like from some particular j to some particular I, where I is greater than n minus 1, which falls under like starting. So this part of the array in the starting of the array, so this one, like this is here, so it is started from here and it is ended till here. So this is our maximum sum subarray parts. So by considering this, we can think like how can we solve. So if it is a case 1, we can get the maximum here, like max 1. And if it is a case 2, so we can basically get this total sum of these arrays. So sum of array, and this we can get the minimum subarray sum and subtract the minimum subarray sum from the total sum. So sum of a minus minimum sum will give us the maximum subarray sum of this case 2, like when the subarray sum maximum from the few element in the starting and few element in the numbers in the end of the array. So this is the main idea behind this algorithm. So let's start the implementation. So the ranges of our numbers is minus 3,000 30,000 to plus 30,000, and the length is also 30,000 from 1 to 39. So with considering this our idea, we can solve this array sum. So first we can find out the case 1 sum. So the case 1 sum max sum, so basically max sum. So let's say, let me define here, current sum is equals to a of 0 and into max case 1 is equals to a of 0. Then we will iterate from int I is equal to 1 and I less than n I plus plus. Let me define here n as well. Int n is equals to a dot length, and here a dot length, and this will be, so our sum will go here, math dot max of cursum plus a of I or a of I. So this is from the standard algorithm problem, Kadane's algorithm, max sum subarray. So you can visit that if you are not already familiar with that. Max case 1 is equals to math dot max of max case 1 comma cursor. So we will get here max case 1. Similarly we can do into, we can find out the sum of the sum of the array, like for int I is equal to 0, I less than n, I plus plus, sum of a is equals to sum of a plus a of I. And now we can get the maximum of min sum of int curmin is equals to a of 0 again. And here we need int min case 2 is equals to, again start with a0 and then again use the for loop int I is equals to 1 and I less than n, I plus plus, and here cur min is equal to math dot min of curmin plus current min plus a of I or a of I itself. And here a of I, and the min case 2 is equals to math dot min case 2 comma curmin. So we will get the min. So in the end we have to check return if min case, if max case 1 is less than 0, which means the total max itself less than 0, so return the same max case 1, otherwise return the math dot max of max case 1 comma sum a minus min case 2. So this is, let's try to run this. So here it is getting running nicely. Let's try other test cases. The test case 1, custom test cases, test case 2, test case 4, test case 3, test case 5, and also try another custom test case 10, minus 3, minus 4, 5, minus 1, 7. So whatever getting, we are getting. Let's try to submit it. Yes, this is accepted. Let's evaluate the time complexity. Time complexity is O of n because we are using while loop. So this can be O of n, and this space complexity, we are just using constants variables, so it's constants. So this is the one solution if you are going. So let me comment out here. So max case 1, and here we got the sum of a, sum of array, and here we calculated the curmin, basically min of case 2, and here in the end we are taking the max case 1, max of max case 1, or the max sum minus a. So this is the solution.